Okay, let's think about these two functions. We're still trying to find the critical numbers and coordinates of the relative extreme. Solution. First, for A, f prime of x gives you 2/3. 1 is a constant, so if you differentiate, that goes away. 2/3, when you differentiate this, 2/3 comes down because of the power rule. And you have to subtract 1 from 2/3. What's 2/3 minus 1? Negative 1/3. And that's same as negative 2/3, 1 over x to the 1/3 power. Which is, if you simplify, this means it's 2 over 3 x to the 1/3 power. Now, since the numerator is a constant, this can never be 0. This is never 0. However, there's one point where the derivative is not existent. Which one is it? This derivative is undefined for what value of x? X equal to 0. So x equal to 0 is a point where the derivative does not exist. So x equal to 0 is the critical number, because there's only one critical number for this function. Okay. Now let's do the same. Place 0 on the number line. Let's plug in 1 and negative 1 and see what you get. What's f prime of 1? Well, it's negative 2/3, 1 over 1 to the 1/3 power. 1/3 power means what? That's cube root, right? What's cube root of 1? Cube root of 1 is just 1, right? So that's negative. You guys forgot cube roots? What's cube root of 8? 2. Cube root of 27? 3. Okay. Cube root of 1? 1. Okay, what if you do f prime of negative 1? Well, it's exactly the same, except now you have to do cube root of negative 1. What's cube root of negative 1? It's negative 1, because negative 1 cubed gives you negative 1. Okay. So for square roots, you're not allowed to have negatives inside the square roots. Right? For cube roots, you are allowed to have negatives. Okay? Cube root of a negative number is still a negative number. That's okay. Okay? So in that case, this is negative 1, so you get negative 2 over 3 times negative 1, which is positive 2/3. So it's positive, bigger than 0. Okay? It's positive. That's your f prime. That means f is increasing and then decreasing. Okay, so what is the x equal to 0? Relative maximum. And if you plug in 0 to original function, what do you get? F of 0 is 1 minus 0 to 2/3. 0 to any power is 0, so it's 1 minus 0, which is 1. So you get 0, 1. 0, 1 is the relative max. So for question A, x equal to 0 is the only critical number, and at x equal to 0, you have a relative max. Let's do question B. For part B, differentiating gives you 1 minus 2, actually plus 2 sine x. This time again, it's always differentiable, so the only thing that we have to look for is when this is equal to 0. What does that give us? That gives us 2 sine x. If I move the 1 to the other side, it gives you negative 1. And then you divide by 2 both sides. So sine x is equal to negative 1. Okay, so let's try to figure out when that happens by drawing the graph of the sine x from negative pi to pi. Okay? See, we're only considering the x values to be between negative pi to pi. So when we try to solve this question, when is sine x equals to negative 1/2, we have to settle this question inside the domain negative pi to pi. Okay, now I told you to memorize the graph of the sine x. You should never forget that sine x graph goes like that, right, at 2 pi. And therefore, if you just draw till pi, this is what you get for the sine x. And because sine x is a periodic function, this thing is repeated over here. So over here, you should be getting that. Now, on this graph, we have to figure out when it gives you negative 1/2. Negative 1/2 happens to be one of those special values, right? Small, medium, large. Which one is this? Small, medium, and large?
Small.
It's a small one, right? Small but negative. Okay? So you should put a small one here, small one there, right? See, inside each 90 degrees, you have small, medium, large, but we're doing the small one. Okay? I guess the easiest one is this one. What is this in terms of degrees? Negative 30 degrees, right? Because you have to say negative 30 because it's this side. In terms of radians, what is it? Pi over 6. Okay, 30 degrees. Negative 30 degrees is negative 180 divided by 6. 180 divided by 6 is 30, right? But 180 is pi in terms of radians, so negative pi over 6 is one such solution. Okay? And this point will be like 30 degrees from negative 180 degrees, right? So because you have to go 30 degrees from this negative 180 degrees, this point is negative 150 degrees. And it's like negative 5 times negative 30 degrees. So you just take this and multiply by 5. Now, that's what I would do, but I know a lot of you have different ways of approaching the trig function. So if you have your own method of figuring this out, that's perfectly fine. But everyone here has to know how to solve such an equation without a calculator. Okay? All right, so the answer to this question is therefore x equal to negative pi over 6 and positive negative 5 pi over 6. All right, on the number line, if I place them, negative pi over 6 and negative 5 pi over 6, I guess you can pick negative pi over 2, and 0 as these test values. Okay, and then we plug it in here. Sine of 0 is 0, so you get positive 1 for f prime. Sine of pi over 2 is 1, but sine of negative pi over 2 is negative 1, so you get a negative here. And sine of negative pi gives you 0, so you get a 1 here, which is positive. So that's your f prime, which means the graph increases, decreases, increases, giving the conclusion that for part B, you have critical numbers, negative pi over 6, negative 5 pi over 6, and this one will give you relative max, and this one will give you relative min. And then to settle this, relative min will be negative pi over 6, comma, when you plug it in here, it will be negative pi over 6 minus radical 3. Sorry, because we don't have time, I'll just compute the values in my head, but given the time, you should be able to do this, okay? All right, and then this one will be negative 5 pi over 6, negative pi over 6 plus radical 3. That's the relative min, and that's the relative max.